Well, hi there! This is an octopus, likely the most intelligent organism on the planet outside of the vertebrates. Incredible problem solving and learning ability in a shockingly short-lived and antisocial creature. I mean, the longest lived octopus on the planet rarely lives more than about 5 years. They have the ability to change not only their color, but their texture on command, to communicate, confuse predators, as well as to disappear entirely. And not long ago, we made a full video about them and all of their closest relatives, the head feet of the class Cephalopoda. But I will tell you that I was not the least bit surprised when I found out that octopuses are closely related to other cephalopods like squids, cuttlefishes, and nautiluses. Even the strangest cephalopods are distinctly cephalopods. But I was shocked when I learned that the closest relatives to the cephalopods were things like these and this. And I didn't even know what this was. But I would not have recognized that as being a close relative to them either. Because, truth be told, cephalopods seem so familiar with their large brains and camera-style eyes. But outside of the vertebrates, nothing else seems much like them. But they are mollusks. And honestly, if you don't get distracted by a few conspicuously vertebrate-like features, they're actually fairly typical members of the group. They have all of the telltale features of a mollusk, if you know what those are. So today, I want to talk about the mollusks, what they are, how to identify them, and which ones are most closely and most distantly related to octopods and other cephalopods. So let's start big. What's a mollusk? I'll start by saying that mollusks are protostomes, which, if you've seen this video before, should bring you some peace. And they are the second most speciose group of protostomes, and in fact animals, just behind the arthropods. Almost a quarter of all described species in the ocean are mollusks, and that's far from the only place that they're found. And they aren't just diverse in terms of the number of species, but in terms of body form, intelligence, and behavior. In all of these ways, they're also spectacularly diverse as a group. But there are a few conspicuous morphological features that, in the absence of knowledge about their genetic and evolutionary histories, unite the group as being related. In general, members of the phylum Mollusca have three major attributes in common. A soft body composed primarily of muscle, a mantle containing the respiratory, reproductive, and excretory structures, which may or may not secrete a calcium carbonate shell. The shells that litter most beaches on Earth are almost exclusively mollusk shells. And given that shells, true shells, are generally defined as being composed of calcium carbonate and secreted by a mantle, it is definitionally true that almost all of the shells on the beach are molluscan, though there may be one exception, which we'll talk about in a moment. But any other similar things that you might find on a beach, like the plastron of a turtle or the exoskeleton of a crab, might be functionally a bit like a true shell, but not true shells. In addition to a soft muscular body and a mantle, mollusks also have paired nerve cords, not a single cord like you likely have, assuming that you're a chordate of some sort. In addition to these three nearly universal attributes, other attributes that are fairly common but not ubiquitous across the group are things like a shell, a muscular foot, an open, as in not in tubes, circulatory system, and a radula, a belt-like bandsaw of teeth for feeding. These things, again, are common but far from universal. So that is what a mollusk is and how you might differentiate one from other animals. So now let's talk about all of the crazy groups of mollusks and how they're related to one another, especially to octopi. And I think I'll start with the mollusks least closely related to cephalopods, because I kind of want to save the cephalopods for last, and also because I want to show you these. This is a chiton in the class Polyplacophora. If you check out tide pools, these are a delightful little creature that you're likely to see fairly often. And most people, at least in my experience, won't know what it is. They look like they could be isopods, and though there are marine isopods, those are arthropods, so not that closely related to these guys at all. Polyplacophorans have a shell composed of 8 plates, also called valves. Later we will discuss bivalves. These are basically octovalves. I've never heard them called that, but tell me why we shouldn't. Polyplacophora means many tablets, which makes great sense. But octovalves really paints a clearer picture in my book. Whatever you call them, these plates made of crystalline calcium carbonate, aragonite, slightly overlap, providing total protection. But because they are many plates instead of a single plate, they allow for some bending of the animal, and yes, like many isopods, they can roll into a ball, conglobate. They are found, particularly in shallow water, in oceans all over the world, generally stuck to a rock. In fact, though they will foray away from their resting point in search of food, mates, and other important resources, many will return to the exact same place on the rock day after day, using a mechanism that we don't totally understand. Though the fact that their radular teeth, the blades on their bandsaw, are made of a ferromagnetic mineral, leads some researchers to suspect that magnetic sensitivity may play a role in their homing ability. Encircling the 8 plates of octovalves is a bit of a skirt called a girdle, which in some rare instances entirely conceals the plates. It too may contain aragonite armor, or bristles, tufts, or other forms of ornamentation. And I want to move on from chitons. We have other things to discuss, but they're just so weird. The anterior-most shell plate is called the cephalic plate, or head plate. And yet, they really aren't very cephalized. They don't have much of a true head. They don't really have a brain, or even a cerebral ganglion. And their sense organs are kind of all over the place. Their mouth is on the bottom. The closest thing they have to a brain is wrapped around their esophagus. The radula is in the mouth, and below the radula is a chemosensory organ called the subradular organ, which is one of their most important sense organs. And they have eyes under their shell plates all over the place that often have lenses made of aragonite, the same crystal that makes up the shell itself. These shell eyes are called aesthetes. Some chitons have thousands of them. They seem to turn the entire chiton into a big compound eye. I could go on for a while longer, but I want to talk to you about their closest relatives. These, the shellless Aplacophora. And this is wild, but though the most recent molecular analysis of the mollusks supports their placement as sister to the chitons, and rather distant from the cephalopods, some analyses in the past have placed the cephalopods as either being sister to this group or indeed part of it. But given the findings of Chen and colleagues this year, we're going to put them here. In fact, their paper is the first new phylogeny that I can find for mollusks in over a decade. So we're probably going to defer to that one for all of the relationships. But there are 2 classes within the Aplacophora, the solenogasters and the Cuttofoviata. And both of them are pretty weird for mollusks, as they lack a shell, a foot, and they have a very reduced mantle. And overall, they just look like worms, which is just a word that means tube-like animal that I don't want to look at any more deeply. But we shall. And if you look at them a bit more closely, in addition to that tiny mantle, their radula and paired nerve cords really give away what they are. Members of the Cuttofoviata are covered in aragonite spines called sclerites, and spend their lives burrowing into soft sediments with just their mouths sticking out, eating detritus as it floats by. Living the dream. The solenogasters, which also have aragonite sclerites, live above the soil, eating or sucking the jelly out of cnidarians and comb jellies, if not eating them whole. As such, they don't use their radulae to scrape food like most other mollusks, and about 20% of them have lost the radula completely. So the Aplacophora and their closest relatives, the Polyplacophora, appear to be the most distant relatives to the cephalopods, which means that everything else we will discuss will be more closely related to cephalopods than they are to these. But, of all the remaining mollusks, all of the rest are more closely related to octopuses than they are to these. The single-shelled, but not spiral-shelled, untorted, as they undergo no torsion, Monoplacophorans. And if you don't know what torsion is, don't worry, we won't forget to talk about it. So you already know that Polyplacophora means many tablets. Aplacophora means without tablets. And Monoplacophora, as you can probably figure out, means one tablet. This group can be contentious depending on how many ancient lineages you try to lump in. It appears that this is pretty much what the common ancestor of all mollusks looked like. So it can be argued that all mollusks are Monoplacophorans.
From a certain point of view.
But as far as I can ascertain, all extant mollusks with one unspiraled shell and no torsion fit into a monophyletic group. This group, Monoplacophora. Though some analyses have put the cephalopods into this clade also. Let's just face it, Everybody wants the cephalopods. I mean, some people get pretty defensive when you tell them that humans and gorillas are more closely related to some monkeys than those monkeys are to other monkeys. I mean, that would make us both monkeys. But every mollusk feels a little bit better if it finds out that it is more closely related to octopodes. Though, as I already said, it now appears that everything we will discuss henceforth is more closely related to octopi than octopuses are to the Monoplacophora. And given that all known extant Monoplacophorans live in the deep ocean, you'll likely never see one. And given that they, like Polyplacophorans, don't really have a true cerebral ganglion, I don't think they will mind much if we move on to all of the closest relatives of the cephalopods. But I will mention that they do have a foot and a radula, and the tip of the shell points towards the front of the animal, which probably isn't what I would have guessed. So, other than the other cephalopods, what are the closest relatives of octopods? Well, these, of course. What an insane creature. Honestly, the longer you look at them, the more alien they become. So bizarre. And I think a big part of that bizarreness is that they aren't all that symmetrical because of torsion. Let's imagine that you're a baby mollusk. You know the things that mollusks tend to have. Well, one day, your head and foot decide to stay right where they are, but everything else decides to turn around and look the other way. You know, your mantle, your shell, all of your organs, they're all now facing the opposite direction. The old twistaroo. And now your mantle and your anus are right over your head, so you can keep a close eye on them. Torsion. And since things in this group like limpets have non-spiraled single-valve shells, it was important to tell you about torsion so you would know how to tell that they aren't Monoplacophorans. But the truth is that most of this group is made up of organisms with either spiraled shells or no shells at all. Because this is the class Gastropoda, the most speciose, at least in terms of described species, class of animals on the planet, except for the insects. And I can guarantee at least one full video just about this group at some time in the future. So let me know if you want that to come at a snail's pace, or if you want a deeper dive into these torted little treasures a bit sooner. But I love gastropods. And unlike everything we've discussed so far, I don't have to go to the ocean to see them. Though the ocean is full of amazing gastropods like limpets, conchs, nudibranchs, which probably need their own video, as well as all sorts of other snails and shellless snails that we tend to call slugs. So they're all over the ocean, but they're also very common in freshwater. Every year our team at Clint Reptiles spends a few days together at Bear Lake on the Utah-Idaho border, living the dream that actually inspired us to create this channel in the first place. This is a freshwater lake, but nearly the entire beach is covered in gastropod shells. And you don't even need to be in the water, because they're all over the land as well. Like these giant African land snails that we found in Hawaii. Or the ever so wonderful banana slugs. I love gastropods. Oh, and just for the record, there is a reason for torsion. Without torsion, not only would you not be able to keep such a close eye on your nether regions, but when you pulled your body into your shell, it would pull the posterior portion in first, and then your head. But doing the old twistaroo, it flipped the script on which bits get protected first, which means that you're faster to protect your noggin. And since gastropods actually have a noggin, I mean, you might as well protect it. That head not only has a good ganglion inside of it, but 2 to 4 sensory tentacles and eyes. Snails show pretty much the full gambit of eyes, from simple light-dark photoreceptors to cups to camera-style eyes with lenses, like we described in this video. If you think the camera-style eye is irreducibly complex, you will be hard-pressed to find a reduced stage of functional eye that isn't present and beneficial in extant gastropods. But though gastropods are among the closest relatives of cephalopods, I mean cephalopods have no closer relatives, they aren't the only closest relatives of cephalopods. Nor are cephalopods the closest relatives of gastropods. Because equally related to cephalopods and the closest relatives of gastropods are these: the Scaphopods and the bivalves. Bivalves are probably rather familiar to most of us. If you've ever walked on a tropical beach, or many not so tropical beaches, even freshwater beaches, then you've probably seen their shells before. But Scaphopods are probably not so familiar, so I'll start with them. Scaphopods are often referred to as tusk or tooth shells for reasons that probably require little explanation if you've ever seen one. Though Scaphopoda means boat foot, And I've received a number of explanations for why this may be the case. I think the most likely one is that the foot is shaped sort of like a boat somehow, but whoever named this seemed to have missed the fact that they look like a tusk. But whatever, I bet you can at least guess that this means that they at least have a foot. Though they're relatively unknown to most people, they're found offshore pretty much all over the world. They're also, based on our fossil evidence, the most recent class of mollusks to appear on Earth, though they're still exceptionally old as a group. And yes, though most of the evidence supports that they are most closely related to bivalves, they have been classified as sister to the cephalopods at times. Everybody wants to be a cat. They'll fish. But their phylogenetic position isn't all we have to argue about with these guys, because it's hard to say what is top and what is bottom, what is front and what is back, which would be a pretty good insult if we weren't so serious about our confusion. I can tell if I'm looking at your top or your bottom. I mean, you're saying it's a front side, but looks more like a back side to me. Burn. The shell looks like a hollow elephant tusk, but it's important that it's hollow because the entire mantle is contained in the shell, with just the foot sticking out to burrow into the substrate. The boat foot, apparently. But in the substrate is where tusk shells tend to spend their lives. In addition to the foot protruding from the shell, a number of small tentacles also reach out and grab food that is then pulled into their ginormous radulae. Proportionally, they have the largest radulas of any mollusk. Which is funny because their closest relatives, the bivalves, don't have a radula at all. But what they do have, as you could probably tell by the name alone, is two shells. In this case, two mirrored halves that hinge together and can completely enclose the soft parts inside. These are things like clams, oysters, mussels, scallops, and many other less familiar but equally recognizable as being members of the Bivalvia. Most of these are filter feeders that live buried in sediments or attached to rocks in both fresh and saltwater environments. And some of them get huge, like this one seen pictured next to an abnormally large human. You are unlikely to confuse bivalves with any other mollusks, though there are some crustaceans that might throw you for a loop, though their little arthropod appendages generally betray what they are. If you were really going to confuse anything with a bivalve, it would be with a brachiopod, and they can be really tricky. They aren't mollusks, but they do have a soft body and a mantle. Both are benthic filter feeders with a two-part shell, so they're a bit of a nightmare. And I'll start by saying that brachiopods are to bivalves as rays are to flounders. Brachiopods and rays are both dorsoventrally flattened and sit upright. Brachiopods are symmetrical with a line of symmetry that divides both valves in half. So the valves are symmetrical, left to right, but the top valve is not a mirrored image of the bottom valve. Bivalves and flounders are both laterally compressed and lay on their sides. Bivalves are symmetrical with a line of symmetry between the two valves. The valves are mirrored images of one another, but they may be asymmetrical top to bottom. Remember, it isn't left to right because they're laying on their sides. They are generally sessile animals that filter food from the water or mud using their gills. That said, some do move around when necessary. Many species can move by extending the foot out of the shell and using that to move themselves around. Others will delightfully use the muscles used to open and close the shell to flutter through the water. You gotta love that. So bivalves, gastropods, and tusk shells appear to be the closest relatives of cephalopods. And if you want to know more about cephalopods themselves, or which cephalopods are most closely related to octopi, you should watch this video right now. As always, like and subscribe, and we hope to see you real soon. I'd like to take a moment just to say thank you to our patrons on Patreon, and to tell you, I've been kicking around a crazy idea, which is that maybe eventually we would do a Clint's Reptiles cruise, or we'd go somewhere cool and do all kinds of Clint's Reptiles things. I don't know. It's just something I've been thinking about, but I think it sounds like a lot of fun. And if we decide to do such a thing, the first people to find out and have access to tickets for this would be our patrons on Patreon. In addition to extra videos every week and a podcast and all kinds of other cool features we have for them, we also tend to make big announcements to Patreon first. So if you want to be the first one to hear about these sorts of things, or just see the other features that we have, or just support this channel, please consider checking it out. You know this song?
No.
Everybody Everybody wants to be a cat.
Aristocats. Okay. You insist. I don't think I've ever seen it, so.
I don't know if I have either, actually.
But you know all the songs.
Great songs.
But that one's hard to miss.